Hello, good morning. In this class, we shall discuss about the basics of Spark SQL. So, how do we read the data? How do we process the data? And what are the different types of formats of data that can be processed by using Spark SQL? Okay, let's go to it. Before that, let me explain you the theory concept of the Spark SQL. Okay. So before going to Spark SQL, just let me give you a brief introduction to the components of Spark. Okay, the Spark is made up of 5 components. The first component would be Spark Core, and second component is Spark SQL. Third component is Spark Streaming. Fourth component would be Spark Machine Learning Library, and fifth component would be Spark Graphics. Okay, so the data storage objects in Spark Core are called as RDDs. RDD stands for Resilient Distributed Dataset, and SQL stands for the data objects in Spark SQL are called as DataFrames and DataSets. DataFrame and DataSet. Remember this. Okay. In streaming, the data objects are called as DStreams. D stands for here discretized. Okay, and MLE, the data objects are called as vectors. And in graphics, the data objects are called as graph objects or frames. Graph objects are frames. Okay, and a Spark application can be launched, can be submitted. A Spark application can be submitted to a local cluster or a distributed cluster. Then simply we can say that a Spark application can be submitted to in local mode and in cluster mode. And again in cluster mode, there are three types of clusters to which a Spark application can be submitted to. One is YARN, another is Mesos, and there is standalone cluster. Okay, standalone cluster. Next, now we shall go to this Spark SQL. So what is this Spark SQL and what we can do in this Spark SQL? So in this Spark SQL, just now we have seen the data holding objects are called as DataFrame and DataSet. We shall discuss later what is the difference between DataFrame and DataSet. But initially now we are going to start with DataFrames. Okay. So these DataFrames are nothing but just like very same as table in some RDBMS. Like a table in RDBMS, a data frame in Spark SQL. Just remember like that. Okay. So like a table in RDBMS, a data frame is also will be in what you call as Spark SQL. So what is the purpose of this? Is this Spark SQL by using this data frames can be used to process structured data and semi-structured data. Structured as well as semi-structured data. It can process structured data as well as semi-structured data. Okay. Structured data in the sense the data that we get that is organized in the form of tables, mainly in the form of rows and columns. Okay, and semi-structured data. What is the type of semi-structured data? The mainly JSON and XML. These types of data can be called as semi-structured data. Okay, and these tables, rows and columns in RDBMS, the data will be stored direct in the form of tables. Okay, and in Hadoop environment, the data is stored in the form of tables only. But the thing is, the storage formats are different, like Parquet, Avro, ORC, RC. Okay, these are the different file storage formats. Not file storage, then table storage formats in HDFS or in Hadoop environment, we can say. Okay, The thing is, Spark SQL can process structured and semi-structured data. Structured in the sense mainly tables, which is represented in the form of rows and columns. These tables in Hadoop environment by using Hive, the data these tables can be stored in these formats, file storage formats, Parquet, Avro, ORC, RC, and okay. The even Spark SQL can be used to process all such type of storage formats. And coming to semi-structure, it can process JSON, XML. I don't think these are the two semi-structured types of data. So Spark SQL can process even this type of data also. Okay, Spark SQL can process. So now, just observe here. It can process structured data and semi-structured data. What about unstructured data? Okay, mainly Spark Core RDD. Spark Core RDDs are mainly preferred to deal with unstructured data. They are used mainly, they're preferred to deal with unstructured data. Okay, but even Spark SQL can be used. Spark SQL can use data sets, not data frames, data sets to process unstructured data, mainly data sets. Okay, data frames cannot be used to process unstructured data, but dataset can be used to process the unstructured data. Okay, so finally what we can conclude from this is Spark SQL. Spark SQL with the help of data frames and datasets. Data frame and dataset. What is going to do with the data frame? It can process structured and semi-structured. Structured and semi-structured. With the help of dataset, it can process structured, semi-structured, and unstructured also. Structured, semi-structured, and unstructured also. Then shall we go with sorry? Shall we go with data frame or dataset? So just by seeing just this unstructuredness, we cannot say that we have to go with dataset. But if the data is structured, which one we have to choose? Data frame or dataset? If the data is semi-structured, which one we have to choose? Data frame or dataset? If the data is unstructured, obviously we don't have any option to deal with data or unstructured data by using data frame. So compulsorily we have to go with dataset. But with respect to structured and semi-structured, which data object we need to go with, data frame or dataset? So I prefer to go with dataset. Why? Because there are certain advantages, certain benefits are there in going with dataset rather than going with data frame. Okay, when Spark SQL was introduced, the first data object to be created was data frame. Later they refined, they added more features, and they renamed and they came up with a new one more data object called as data set. That's the thing. But now this is not deprecated data frame. In future versions of Spark SQL, this data frame may be deprecated. We may have only data set. Okay, so certain advantages are there. We shall see what are those advantages later, but just now try to remember that which one you would choose, whether data frame or data set for processing. So simply say that I simply say that choose data set instead of going with data frame. Okay, why? Because it has certain advantages. Okay, not just disadvantages, there are some advantages as well. We'll come to those advantages later. Why? Because it will create some confusion and we may not understand at this stage. Okay, now let me show you how to create these data frames. First we shall start working with data frames, then later we shall go with data sets. Okay, data frame. Okay, so I already told you that data frame. What is a data frame? It is something like a table. It is something like a table in RDBMS. Okay, it is represented to us in the form of a table only. Okay, it is represented to us in the form of a table only, but only thing is that we call it as the data frame. That's it. Okay, now practically I will show you now how to create a data frame, how the data is represented to us in the data frame. That those practicals we shall try to see now. Okay, now see here. So now, as we are not using dataset, okay, suppose we are not using dataset, let us say we are using data frame only, but we have unstructured data, then how to convert the data into structured data? Okay, if we have a data frame can process what? Structured and semi-structured only. But if the data is unstructured, don't we have any possibility or any alternative methods, any alternative approach to convert this unstructured to structured and or semi-structured so that data frame can process it? Do you have any option like that? Yes. If the data is unstructured, you can pre-process the data by using RDDs. Okay, and later you can convert that unstructured data into structured data. Okay, remember this. So if the data is unstructured, directly you can either go with the dataset or you can use RDD. You can extract the required information from that unstructured data and you can form the structured data out of it. Now we can use data frame to process that data. Is it clear? So now we are going to see first this approach. Okay. So as you know already, for the creation of data frame, sorry, for the creation of RDD, what is the data, what is the context that is required? Spark context. Spark context is required to create RDD. And what is required to create data frame or dataset? We require SQL context. Remember, we require SQL context to remember to uh, create data frame or dataset. Okay, now we are going to see practically how to create our RDD and how to create data frame and dataset and how to process the data. Okay, right. So this is the Cloudera environment. In this I am going to start Spark application. So for starting Spark application, simply type the command here spark hyphen shell. So this spark hyphen shell is going to launch this Spark application in local mode. By default, the mode will be local mode. Okay, just let us submit it. So Spark Cloudera 5.10 uses Spark version 1.6.0. Let the application start. It may take few seconds. Okay, it doesn't take much time. Okay, it has started, almost completed. So it is showing the version here, Spark version 1.6.0. We can see here the master is local, that is Spark application has started in local mode. Okay, it has started. Now first we shall create one RDD. Val RDD1 equal to SC. SC is the Spark context. So I'm loading some unstructured text file now. I'm loading it from HDFS. Localhost colon 8020 slash user slash Cloudera slash call logs data. There's a file called call logs data in this. Let me store this. So let us see whether we have data in this call logs data RDD or not. Then let's try to see. Try to print 2 records. Yes, we got the data. Okay, now roll. Now let me print 10 records. How to print 10 records of RDD? RDD dot take of 10, and every line. If you want to print 1 record per line, try to use this command. Okay. Now you can see this. These are the records. Okay. Now from these records, there is no proper delimiter here. This is not a CSV file. This is not a TSV file. No, there is no proper delimiter between the fields here. If we observe the call log data here, this is the status. In every record we have the status. Here in the first record the status is dropped. In the second record the status is success. Third record failed. Likewise, we have 3 different types of status in all the records. Okay, and these are the phone numbers. Okay, first 10 digits will give the phone number of the first number, and second part, that is remaining 10 digits will represent the second phone number. Okay, dialing number and a dial number. And similarly here we have timestamp from here to here. You can observe this is the starting time of the call, and this is the end time of the call. Now we are interested in to find out the starting time of the call, ending time of the call, status, and these phone numbers. Okay, so I should have these four. What way I should have? My requirement is like this. That is, I should have a table. Now I should have a table such that the shape table should contain 5 columns. The table should contain 5 columns. What are those 5 columns? The first column is start time of the call, start time, and second is end time of the call, and the third is the status of the call, and finally the from number, that means the dialing number, and to number, that is the dialed number. So I need to have the data in this form. Okay, I need to have a table like this. Table in the sense, in sparkSQL, the table is called as data frame. So I would like to create. Now we should have a data frame with these columns and the data. So start time, from each record I have to get start time, end time, status, from number, and to number. But if you observe the data here, the data is not separated properly. Okay, it's not separated properly, it's not delimited. There is no proper delimiter between the fields that we want here. Then what shall we do for that? The thing is, we need to pre-process, we need to extract the required data from each record by using the RDD transformations, RDD operations. Okay, how do we do that? Okay, to extract these fields, first we need to take the help of regular expressions on RDDs. Okay, we have to use RDD operations, but internally we have to use regular expressions concept. Then only we can extract, matching a particular pattern, we can extract this data. Okay, let us do this now. Okay, the very first thing is we shall try to see how to extract this status and how to extract these, what are these phone numbers, and later we shall see how to extract this starting time and the ending time. Okay, let me start. First define a pattern for status. I write status underscore pattern equal to, I write like this. So what is the pattern here? You can observe here the status is made up of all the capital letters. Okay, dropped, success, or failed. It is having either dropped, success, or failed. We can specify like this: dropped, or success, or failed. Close it. Sorry. Close it. Dot or represents it is a regular expression. Okay. Second one. Val phone numbers. Phone number underscore pattern equal to. So what are the phone numbers? The phone numbers are made up of 20 digits. Okay, it is this made up of 20 digits. So the corresponding regular expression would be like this. So 0 to 9. Okay, how many digits totally? 20 digits. So 20 digits. Okay, just close it. Dot R. This is the regular expression to extract this information. Okay. Next, to extract the first, the starting time and the end time. How to extract this? Well, start time pattern equal to start time pattern equal to we specify the pattern like this. Okay, so see here it is starting with 2014, that is 4 digits, hyphen followed by 03 hyphen 15. Likewise we have this. Now what it is, see how I am going to write this. Okay, now 0 to 9, how many digits exactly? 4 digits. Okay, followed by hyphen and again digits. How many digits? 0 to 9, 3. It is two digits here. 4 digits, 2 digits, and again 2 digits. Hyphen followed by 0 to 9 and again 2 digits. Space. There is a space. So you can use directly space here. Space and again 2 digits. 0 to 9 and again 2 digits. Now it follows by colon and again 0 to 9, 2 digits. Okay, and again followed by colon and again extract only 2 digits from there. Okay, so 0 to 9, only 2 digits. That's it. Dot R. Okay, dot R. This is the start time pattern. Next, finally, well, end time pattern. So in the end time, the pattern is same. What are the pattern that we are using for start time? The same pattern we have for end time. So there will be confusions for the processing, which one to extract. So to avoid that confusion, we shall include an extra. We shall include an extra one character from the each record, and later we shall delete it. Okay, so let us see how do we do it. We are going to do it. Now I am going to call it as end time pattern. And after extracting these two, what I am doing is I am calling it as sum followed by dr sr f. Okay, followed by this. Later we shall extract, later we shall delete this. Why? Because just I am trying to show the difference between these two. To extract the start time pattern separately and end time pattern separately, I am using this extra dsf. That's it. Why? Because these two have the same pattern. Okay, now let us see how we are doing this. How we do this, then just let us see now. Now, well, RDD2 equal to RDD1 dot map of x implies the first one. Well, what do you want? Start the time underscore time equal to start time equal to what is the start time here? So for the start time, what is the pattern that we are using? Start time underscore pattern. Okay, use that. Start time underscore pattern dot find first in x dot get. Okay, next val end time underscore pattern equal to sorry, end underscore time equal to end time underscore pattern dot find first in x dot get. Next, finally, val after this what we are trying to look for status. Val status equal to so the pattern for status is status underscore pattern here. Okay, status underscore pattern dot find first in x dot get. Finally, val phone numbers. Phone number equal to phone number underscore pattern dot find first in x dot get. And finally, print this start underscore time comma end underscore time comma status comma phone number comma, so that's it, phone number, and close it. Okay, now just try to print RDD2. Now see, let us see what happens. Let RDD2 of take of 10 dot for each of println. Okay, can you see here now? The first field is start time. It is extracted successfully. Just let us see now. Let us try to print RDD1 also. We understand. Okay, this is the actual data. This is the data we have taken as input. Okay, and this is the output we got here. Okay, this is the output. Can you see here? We could extract the start time here from here to here. So this is the first record, first element. And what is the second element? The end time from here to here 5, and from here to here 5. And we have one character extra. We shall extract. We shall delete this character now. Okay, in the next transformation, next operation, we shall delete this. And we got the status, and finally we got the phone numbers. Now our task is, in the next operation what we have to do is we need to extract this extra character, eliminate that extra character, and we need to separate these two phone numbers. Because the two phone numbers are mixed up here, we need to separate these phone numbers. Okay, so finally we are going to make up 5 columns. Now here we have only 4 columns, 1, 2, 3 and 4. But finally we are going to make 5 columns. The columns will be like this. First column will be as it is, the data. Second column, we are going to delete this extra character. The third column will be as it is, and from the fourth column we are going to divide it into 2 columns. One is the from number, another is the to number. Okay, let us see how we are going to do this. Okay, now well RDD3 equal to, see what we are going to write. RDD2 dot map of x implies, so what do we want from this x? Okay, x dot underscore 1. So as this collection, every record is a tuple, we access the elements of the tuple by using dot underscore 1. Dot underscore 1 represents first element, and dot underscore 2 represents second element. Okay, next x dot underscore 2 dot. So this is the second element. From this, what we want here, this extra character has to be deleted. So for that, what shall we do now? Okay, for that we can use operation called as slice of. So from where to where you have to have this, from the starting character to the last but one character. So how do you decide that? That is slice of 0 comma, the index of character starts with 0. Okay, the numbering of character starts with 0 to where you want x dot underscore 2 dot length till the entire length minus 1, last but 1. Okay, next comma, third field as it is x dot underscore 3, and fourth field we have to divide it into 2 columns. So now slice first 10 digits and slice second 10 digits. Okay, how do we do that? That is x dot underscore 4 dot slice of 0 to 10. So it will take up to 0 to 9 only. Okay, 0 up to 9 it will make up of 10 digits, but here we have to supply 10. It will exclude this value. And after that, x dot underscore 4 dot slice of 10 to 20. So it will take up to 10 to 19. Okay, is everything clear? I think everything is clear here now. Right. I think one more brace somewhere it is missing. Let us see, do we have proper? So this is the first field, this is the second field, okay, and this is the third field, this is the fourth field, and this is the fifth field. Okay, fine, it is fine now. Now try to print this RDD3 data now. RDD3 dot take off 10 dot for each of println. Okay, now can you see now here? This is the start time, this is the end time, this is the status, okay, and this is the from number, and this is the to number. Fine now. Now we got from the structured unstructured data. Let me show you now. So unstructured data that we have in RDD1 initially. Okay. Now finally we got the structured data. Okay. Now we could able to separate this data and extract our required information from each record. That is start time, end time, status, from number and to number. We are able to extract now. Okay. The only thing is now we need to form a data frame now. We can create a table for this now. How to create a table for this? Let me show you now. That is, the table is nothing but a data frame. Now how to convert this RDD into a data frame? It is very simple. It is a matter of only one statement, that's it. Okay, while data frame, I use df equal to, let me use df1 like this, df1 equal to RDD3 dot to df of, and what has to be the first column name you want to name it as? I want to name the first column name as start time, and second column name as end time, and third column name I would like to name it as status, and fourth column name I would like to name it as from number, and fifth column number I would like to name it as to number. Okay, that's it. It will work. Dot to df is, okay, it is used to convert RDD into a data frame. Let us see what happens with this. It has to work. Let us see. It is taking some time. Okay, now it is processed. Okay, start time, end time, status, uh, from number to number. Let us print this data now. df1 dot, we use the operation show of some 10. Can you see now how the data is organized? Now the data is organized in the form of a table, right? It is something like a table. It is a table only. Okay. So the first column, second column, third column, fourth column, and fifth column. Everything is fine now. Okay. So we use the operation show to display the number of records. Number of, no, we don't call them as records now. We call them as rows now. Okay. Df to display certain number of rows. We use the operation show of, give that figure, those number of rows will be printed. Okay, this is how we process. We take some unstructured data, pre-process it by using RDD operations, and later convert that RDD into a data frame by mentioning the column names for the data frame. Okay, this is how we pre-process the data. Okay, is it clear now? Right. We can perform, whatever the analysis we can do, we want to do, we can do on this data. Okay, let us perform some operations here. I would like to select only, I would like to filter the data based on what I would like to select only drop the records. How do I do it is df1 dot select star dot where. Here supply the condition where status equal to, what is the status here? Dropped. Keep it in single quotes, not double quotes. Status equal to dropped. Okay, dot show of some 10. Okay, now can you see here what are the where the status is dropped? It is showing only those records. Okay, now if you want to see how many dropped number of rows are there, the rows containing dropped, total how many rows are there, for that we can do directly, instead of show you can use count. Will show the number of rows where the status is dropped. So it is processing the data. Okay, can you see here there are almost 1,04,642 records are there. Okay, so you can run many of the queries, many of the filter operations and some join operations. You can do any type of operations. Okay, once we form data frames. Okay, so I think this video will give you sufficient information of how to create a RDD from unstructured data, how to do pre-processing, and how to convert that pre-processed data into a data frame. Okay, so that we can form a table and we can work with that. Okay, thank you for watching the video, thank you for attending the class. Okay, for the updated videos, for updated class videos, you can subscribe to my channel. Okay, thank you, thanks 11.